Okay, so this is the first question. There's only three, I believe. Given a test to a group of students, the grades and gender are summarized below. If one student is chosen at random, find the probability that the student was male and got an A. So it's going to be when you have the table here. I know in the notes we talk about and probabilities where we multiply to find the result. That's when you're doing more than one thing. Here we're just picking one person, so we don't need any formula. We're just looking for the specific group of people that satisfy both of these characteristics that are male and got an A. So out of the entire 62, there are only 4 males that got an A. So this answer would just be 4 out of 62. You don't have to find the probability of a male and the probability of an A and multiply them together. That's not necessary here. It's just the people who are male and got an A, which is these 4 out of the 62 total. Okay. Now this says find the probability that a student was not a female that got an A. So if we're going to find the probability of not something, it'll often be easier to just find the probability of that thing and then find the complement. Female and A. So what is the probability of selecting a female that got an A? Well, there's 72 people total. So of the 72, females that got an A is 17 out of 72. So if I want to find the probability of not female that got an A, I can simply just do 1 minus, and then I'll do 17 divided by 72. You can put the decimal in, or you can hit math, enter, and get the fraction, which is 55 over 72. And the last one says we have this table here. One of the pedestrian deaths is randomly selected. One is selected. Find the probability that the pedestrian was not intoxicated or the driver was not intoxicated. So whenever you see or, even if you're selecting one thing, we need the formula. The probability of A or B is equal to the probability of A plus the probability of B minus the cases where both happen. So minus the probability of both A and B. So this would be the probability that the pedestrian was intoxicated. So that's all accidents where the pedestrian is intoxicated. That's these two groups. So that's going to be 52 plus 273. That's 325 over 977 plus the probability of B, the driver was intoxicated. That's going to be these two. Whoops, let me redo that. These two. That's 52 and 80. That's 132 over 977. But now you'll see that I actually counted a group of people twice, which is this 52, which is the probability of both. The pedestrian and the driver was intoxicated, so I have to subtract 52 out of 977. So luckily we can just do this in the calculator, and it's pretty straightforward. We do 325 divided by 977 plus 132 divided by 977 minus 52 divided by 977. If you want to keep it as a fraction, just hit math, enter, and it'll fix it for you. They want percentages. So let's do 405 divided by 977. And we get 41.4.